Here we are taking the basic concept, important terms and formulae of unit number 6, gravitation. And the first one is the force of attraction between any two bodies in this universe is known as gravitation. The second important thing is the force of attraction between the body and the earth is known as gravity. The third point is about the Newton's law of gravitation, and according to that, the gravitational force of attraction between any two particles in this universe is directly proportional to the product of masses of these two particles and inversely proportional to the square of distance between these two particles. If m1 and m2 are the two bodies having the masses, and r is the distance between m1 and m2, then this force of gravitation is directly proportional to the product of the masses and inversely proportional to the square of distance between them. And the g, it is the universal constant of gravitation in CGS system. The value of G is 6.67 into 10 power minus 8 dyne centimeter square per gram square. In SI system, it is 6.67 into 10 power minus 11 Newton meter square per kg square. The acceleration produced in a body on account of a force of gravity is known as acceleration due to gravity, and it is denoted by small g. The next point is about the value of acceleration due to gravity on the surface of Earth. It is given by capital G, gravitation constant, into the mass of Earth upon the square of the radius of Earth. The next is about the mean density of the Earth. It is given by rho 3 into acceleration due to gravity divided by 4 pi gravitation constant into the radius of Earth. The seventh point is about the inertial mass of a body. It is a measure of the ability of a given body to oppose the production of acceleration in the body of an external force. Another is gravitational mass of a body. It is the mass of a body which determines the gravitational pull between the body and the earth. The inertial and the gravitational masses, they are equivalent. The 10th point is about the gravitational forces, that is between the two bodies. They are Newtonian in nature. That means the forces are equal in magnitude and opposite in direction and act on different bodies. The 11th point is about the height h of a body above the surface of Earth that cannot be neglected in comparison to the radius of the Earth. Then the value of acceleration due to gravity at the height h is given by the relation gh upon g. Gh is the acceleration due to gravity at the height h divided by the acceleration due to gravity on the surface of Earth. This is equal to the radius of Earth square divided by radius of Earth plus height on which the object is there to the whole square. However, if the height h is very small as compared to the radius of Earth, then we can write down this relation. The acceleration due to gravity at the height h is given by acceleration due to gravity 1 minus 2 into height upon r. The loss in weight of a body at a height h, when it is very less than the radius of Earth, is given by 2 mgh. G is acceleration due to gravity and h is height. M is the mass of that body divided by the radius of the Earth. The variation of acceleration due to gravity with depth d is given by Gd is the acceleration due to gravity at depth d. It is given by G, acceleration due to gravity 1 minus depth upon the radius of the Earth. Now, the 14th point is about the acceleration due to gravity, and hence the weight of a body at the center of the Earth is 0. The value of acceleration due to gravity at a place on the surface of Earth varies inversely as the square of the radius of the Earth at that place. The value of G increases as we move from the equator to the pole, and the variation of acceleration due to gravity with latitude phi is given by the relation G dash is equal to G minus R omega square cos square phi, where angular velocity of the earth about its own axis is denoted by omega. At the equator, phi will be 0, and in that case the acceleration due to gravity at the equator is equal to G minus R omega square. And at the pole, the phi will be equal to 90 degree, and in that case at the pole it is equal to the acceleration due to gravity. The 18th point of the basic concept is about the centripetal force that is required by a satellite to move around the earth is provided by the gravitational force of attraction between earth and the satellite. So this is a very important concept. The most important thing about the satellite is the satellite is moving with the gravitational force of attraction between earth and the satellite, as it is providing the centripetal force. The orbital velocity of the satellite is given by VO, stands for the orbital velocity, under root of G, gravitation constant, M mass of earth, and R is the radius of the orbit of the satellite. And R is given by R is the radius of earth plus height above which the satellite is revolving. So R is the radius concerned about the orbit of satellite from the center of the earth, where h is the height of the satellite above the surface of the earth that I mentioned. And in place of this r, we can write down capital R plus h, radius plus the height above which the satellite is. And this value is concerned with the acceleration due to gravity at the height, and this is given by gh in the bracket r plus h. Or we can also write it down like this: r radius can be taken outside and g over r plus h. If the satellite is orbiting close to the surface of the earth, then orbital velocity is equal to under root of acceleration due to gravity into r. It means here the relation that we have taken, h is neglected in this case, in the case if it is very close to the surface of the earth. So h can be neglected here. The period of revolution of satellite is given by capital T. It is equal to 2 pi r by orbital velocity. And this r can be replaced by capital R plus h, where r is the radius of earth and h is the height of the satellite. T can also be written as 2 pi r plus h whole square by capital G, gravitation constant, mass of earth, under the root. The height of satellite above the surface of earth is given by the relation h is equal to acceleration due to gravity small g r square, radius of earth t square, time period, upon 4 pi square to the power 1 by 3 minus r. A geostationary satellite is a satellite which appears stationary to an observer on earth, because its time of revolution is same as that of earth, so it appears that the satellite is stationary. This satellite is also known as synchronous satellite or artificial satellite, or this is used for communications. That is why it is called a communication satellite too. Now, there are the following conditions that must be satisfied by a geostationary satellite, and in that the satellite should be at the height of nearly 36,000 kilometers from the equator of the earth. Continuing with the condition that should be satisfied by geostationary satellite, before that we have done satellite जो है अगर जियो स्टेशनरी है तो वो नियरली 36,000 किलोमीटर अर्थ सरफेस से अबव होना चाहिए. The next condition is the satellite should revolve in a orbit which is concentric and coplanar with the equatorial plane. Next is the sense of the revolution of satellite should be same as that of Earth. The next important thing is the orbital period of satellite should be same as the time taken by the Earth to complete one rotation about its axis, that is 24 hours. The next is about the escape velocity of a body, and this is given by the relation under root 2 G m by r. G is the gravitation constant, m is the mass of Earth, and r is the radius. This thing can also be written as 2gm multiply and divide by capital R. So gm by r square will become acceleration due to gravity. So we can write down the above relation as under root 2g r. 2r is the diameter, so escape velocity can be given by under root gd. In terms of rho, that is the density of Earth, escape velocity can be written as 8 pi g rho divided by 3 under the root. The next is about the gravitational field. It is the region around a mass or an assembly of masses over which it can exert gravitational force on the other masses. The next is the gravitational field intensity at a point. In the gravitational field is the force experienced by a unit mass placed at that point. The next is the gravitation potential at a point in the gravitational field is the amount of work done in bringing a unit mass from infinity to the given point. The next is about the gravitation potential at a distance r from the mass m is given by V is the potential minus gm by r, where g is the gravitation constant, m is the mass, and r is the distance at which it is being taken from. Next is the gravitational potential energy of two masses capital M and small m separated by a distance r is given by, this is the gravitation potential energy, minus gmm by r. Here the negative sign arises due to the attractive nature of the gravitational force. Here we are talking about Kepler's laws. First thing about them is the Newton's law of gravitation is derivable from the Kepler's law. And first law states that it is also known as the laws of orbits. It states that each planet moves in an elliptical orbit with sun at one focus. The second law, that is also known as the law of areas, the speed of planet varies in such a way that radius vector drawn from the sun to the planet sweeps out equal areas in equal times. In other words, aerial velocity of planet is constant. For example, the sun is at this position and in this elliptical orbit A1 area is swept in time t2, A2 area को स्वीप करने के लिए टाइम t लगा है और A3 एरिया को भी स्वीप करने के लिए टाइम t लगा है. सेम टाइम जो है उसके लिए जो एरिया स्वीप करेंगे दैट विल बी इक्वल, that is A1 area equal to A2 equal to A3 because time taken for sweeping out is same. The third law, that is also known as the laws of periods. According to that, the square of the period of revolution of a planet around the sun is proportional to the cube of semi-major axis of the elliptical orbit. Mathematically, it can be written as t square. T square is the period of revolution. T is here the period of revolution is proportional to r cube, where r cube is the radius of the semi-major axis from the elliptical orbit. So t square is proportional to r cube.